Okay, so hopefully this is recording now. So I want to talk about factoring. And before I get to factoring, let me first talk about distributing, because that's the kind of the more basic idea. So, so this is the first example. Let's do 2 times x plus 3. So distributing is when you do this. We did one example like that earlier. You take the 2 and multiply by the x to get 2x. 2 times 3 is 6. This is called distributing. Now sometimes distributing is a little bit harder. So here's another example, distributing. 2x plus y, 3x minus 4. So if you want to distribute in a situation like this where you have 2 things added, in parentheses multiplied by 2 things added, or subtracted, I think of subtraction and adding as the same thing, then what you have to do is basically FOIL it, or basically you're going to take every combination here with every combination here. So like the 2 times the 3x is 2 times 3 is 6, x times x is x squared. 2 times negative 4, that's going to be negative 8, and we still have the x. Y times 3x, not a lot to do with that, you just kind of put it all together, that's plus 3xy. And y times negative 4 is minus 4y. So that's called FOILing up a lot of the times, because this is the first term, this is the outside term, this is the inside term, and this is the last term. That spells FOIL. If you take the first letters of each of those words. What we want to do, what this spiel is actually about, is reversing this process, going from the blue to the black. That's called factoring. So that's what I want to talk about now. And depending on the algebra class, doing an algebra, you may have never seen this before. In which case, this is going to be kind of a little bit rough at first, but we're going to be doing a lot of factoring in this class, and I think you'll get it down by the end of the class. So let's do a factoring example. So the first type of factoring, and this is kind of the one to always look for. So if we want to factor this, the goal is, so I'm going to switch over here back to the previous page. Here we were distributing, we're kind of putting the 2 into the parentheses. Here we want to do the opposite. We want to bring something out and create some parentheses. And the thing that goes into both of these numbers, the 14 and the 35, would be a 7. So I'm going to take out a 7. And factoring is kind of like division. I'm going to take the 7 to 14 to take the 14, divide by 7, and get 2. And the x kind of just comes along. And 35 divided by 7 is 5. So there we go. We factored this by pulling up the 7, basically. So that's the type of factoring that is kind of the nicest thing to do. Let me just do another example of that. So so a little bit more complicated, but basically the same idea would be 9x cubed minus 51x squared plus 45x. So to factor this, again, we want to pull something out like we did the 7. Now, the only number that goes into 9, 51, and 45 I believe is 3. So we're going to take out a 3 here. But we can also take out an x, because x goes into x cubed, x goes into x squared, and x goes into x. We're also going to take out an x. So I'm going to do 3x, open my parentheses. And then it's like division. 9x cubed divided by 3x is 3x squared, right? X cubed divided by x is x squared. 51x squared divided by 3x is, well, that's kind of hard. 51 divided by 3 is 17. And x squared divided by x is x. And then finally, 45x divided by 3x. 45 divided by 3 is 15. And x divided by x is just 1, so I can just leave that off. And that would be factoring. Now, we are going to maybe want to try to factor this too, this 3x squared minus 17x plus 15. This one actually doesn't factor, so we're actually done on this problem. But this could factor further by kind of unfoiling. Hold on one second. Okay, we're back. So that's the other type of foiling, factoring I want to do, which is kind of unfoiling. So over here we foiled when we did the second problem on this slide. We want to undo that now. So that's going to be a new slide. Let's do one of these here. Okay, so x squared minus 8x plus 15. And we're going to talk more about how to factor this tomorrow. And we're going to have lots of different ways of factoring it. But for right now, let's just give it a shot. So I want to unfoil this. I want to factor it. I want to unfoil. So by unfoil, I mean I want to turn it into something like this. Or we have like x plus something and x plus something. Or maybe it's minus something. And what I really want to do is just fill in these numbers. Well, what do these numbers do when you foil them? Well, let's go back to this example. Oh, actually, this maybe not this example. Actually, let me just do a new example of foiling. So let's just do x plus 1, x plus 2 real fast. So when you foil these, you're going to get x squared plus 2x plus x. 1 times 2 is 2. And so you get an answer of, a little bit here. There we go. You're going to get an answer of x squared plus 3x plus 2 for this random red problem. So this red problem is not the problem I'm actually doing. I'm just trying to illustrate for a second here. Okay, so this red problem is a separate problem, but this is going to tell us what these two numbers are going to be doing. So these two numbers, they multiply to get the constant term of our quadratic, which is just the name for just the number at the end. And what they do is they add to get this 3, right? So that's exactly how we're going to figure this out. We're just going to say, okay, these two numbers, they're going to add to my middle term here, my -8. And they're going to multiply to my constant term here, the plus 15. And so kind of using this framework, it allows me to fill in these numbers. I'm looking for two numbers that multiply to 15 and add to -8. Okay, so how do you actually figure out the numbers? Well, I like to start with the multiplication, actually. Because I know there's not very many ways to multiply to get 15. There's 1 times 15, and there's 3 times 5. That's basically it. 1 and 15 are probably not going to add to -8, but the 3 and the 5 seem promising, right? So I'm going to kind of fill in my 3 and 5 here. So this is looking pretty good. 3 and 5 do multiply to 15. They kind of add to -8, but they actually add to +8. That's a little bit of a problem, but actually easy to fix. What you can do is just flip the sign to all of them, because -3 times -5 still adds to still multiplies to +15, and it adds to -8. So that's actually the answer. We just kind of fill these in, and you could write this as x minus 3 and x minus 5, but this is fine too. There you go. We've now factored this one. Let me just do one more example, and then I will let everybody go and stop the video. So if we want to factor this one, how might we do this? Well, if you see anything with a cube, your guard should be up a little bit. We haven't talked about factoring a cubic yet, and it tends to be a little more difficult to factor a cubic, but this one's not so bad. What you first notice on this one is that each term has an x in it. So we can actually factor out an x. And when you do that, x cubed divided by x is x squared. 3x squared divided by x is just 3x. And 10x divided by x is just 10, or minus 10. Once you factor out that x, now you have a quadratic. I do want you to continue factoring. So let's kind of continue factoring this, but that's a really great first step because it really simplifies the problem. So now we want to turn this into a FOIL situation because we recognize this as a quadratic with 3 terms that looks like it came from a FOIL. So x plus or minus something, x plus or minus something. What are those somethings? Well, if you remember what we were just talking about, these two somethings multiply. They multiply to -10. And they add to the middle term 3. If you ever forget which one is multiplication, which one is adding, you can always do, like I did with this little red example over here, you can always just multiply one out real fast to kind of see how it works to remind yourself. By the way, we need 2 numbers that multiply to -10, add to 3. Well, the only things that multiply to 10 are really 1 and 10 and 2 and 5. And so I think 2 and 5 is going to be a little bit more likely here. But of course, 2 plus 5 doesn't add to 3. But if we make one of them negative, I think that's going to work out. So if we make the 2 negative, then I think this all works. -2 times 5 is -10. -2 plus 5 is 3. Looks good. So we're basically done with the problem now. So we just kind of fill these in, these blanks, and that's how it factors. Don't forget the x. We still have the x because that's part of factoring is you get all these different terms. Okay, I am going to stop the recording.